Hey everybody, welcome back to chemistry. I'm going to solve another Achieve problem. This is on Achieve assignment 6. This is question 6. So if I can blow up the slide, please. So it reads as follows. If your front lawn is 15 feet wide and 20 feet long, and each square foot of lawn accumulates 1,350 new snowflakes every minute, how much snow in kilograms accumulates on your lawn per hour? Assume an average snowflake has a mass of 2.10 milligrams. Okay, if I can reduce the slide. Okay, so I consider this to be a fairly difficult problem. And so what I first want to do is let's first figure out where we want to end up. So to me, it looks like where we want to go is they want to know how much snow in kilograms accumulates on your lawn per hour. So it may first seem like you want to get kilograms in the end, but really it's not quite that. They want to know the rate you get snow on your lawn in kilograms per hour. So we're really going to end up here with kilograms per hour. Okay. So now let's look at some of the starting information and think about where we may want to begin. So one thing I see here is that we have dimensions of the lawn. It's 15 feet wide by 20 feet long. Okay, so I'll talk a little bit more about that in a second. And then we're given a rate at which the snow accumulates per snowflake per minute. So it says 1,350 snowflakes, and so I'm going to abbreviate snowflakes SFS, so just know that this is snowflake. So it's 1,350 snowflakes per minute, okay? So over 1 minute. Okay, and then we're told the mass of every snowflake is going to be 2.10 milligrams of a snowflake for every one snowflake. Okay, so one thing I can't help but notice is that we have dimensions here of an area. You can see that feet times feet is going to be feet squared. So let's go ahead and just multiply these two numbers and then work with that. So 15 feet times 20 feet, I worked it out earlier, is 300, and it looks like we need three significant figures, so I'm going to put a decimal there, feet squared. Okay, so again, you can probably start out with any of these numbers as your starting point, but let me just start out with this area first, and I think the problem becomes a little bit easier to solve if you do that. So I'm going to start out with 300 feet squared of lawn. And what we're trying to figure out is how much snow in terms of kilograms per hour will fall on 300 foot squared lawn given these parameters. So we have the area of the lawn, which is 300 feet squared. So what I might first do is try to convert this into snowflakes per minute. That's a little tricky to do, but I'll show you how to do that. And then once you're at snowflakes per minute, then the problem isn't so difficult to solve. Because if you're at snowflakes per minute, you know how many milligrams there are in a snowflake. So you can get milligrams per minute, and then you can convert milligrams eventually to kilograms per minute. And then what you can do is convert kilograms per minute to kilograms per hour. Okay, so that's the way we're going to go. Okay, so let's go ahead and try to solve this. Okay, so we have 300 feet squared of lawn. And so notably, we have that conversion there. It's 350 new snowflakes per minute, so it's 1,350 snowflakes per minute. Now, there's something else I want you to see. So let me read the full sentence there. It says, and each square foot of lawn accumulates 1,350 new snowflakes per minute. So it really isn't so much 1,350 snowflakes per minute. It's a little bit more than that. It's 1,350 snowflakes per minute per square foot of lawn. So the question you might ask yourself is, well, how do I write that out in terms of a fraction? So the way you go about doing that, again, we want 1,350 snowflakes per minute per square foot of lawn. you can put foot squared like that. That will work, okay. So now I think you can sort of see that you can sort of add this fraction here and feet squared cancels out and you get snowflakes per minute. So let me go ahead and put that there. So it's 1350 snowflakes per foot squared times minute. And so you can sort of see now that foot squared cancels out. And now you have it in snowflakes per minute. Okay, so what's the next step? Next step is you have to get this in milligrams per minute. So that's not so difficult to do because you can see that every snowflake has a mass of 2.10 milligrams. So we have 2.10 milligrams over one snowflake. And so here you can see the snowflakes cancels out. And so right now we're in milligrams per minute. And then to get from milligrams to minute to kilograms per hour is probably something you know how to do. I'll just write out the fractions really quickly. So the next one would be what? You have 1 milligram here, 1 times 10 to the negative 3 grams here to get milligrams to grams. Now we have to get grams to kilograms. So what we want here is we want 1,000 grams here, and then we want 1 kilogram there. And now let's see what cancels out here. We have milligrams cancels out, we have grams cancels out. Now we're in kilograms per minute, but we want it per hour, so we have to convert minutes per hours, or to hours, excuse me. And so what we want to do is we want 60 minutes here over 1 hour in the denominator. So let's go ahead and do the math. It's 300 times 1350 times 2.10 times 1 times 10 to the negative 3 times 60. Divide by 1,000. And so when I did this earlier, I got on my calculator 51.03 kilograms per hour. Now, this is probably going to be rounded to 3 significant figures. Here, 300 feet was 3 significant figures, as I explained earlier. 1350 snowflakes per feet squared per minute is 3 significant figures. 2.10 milligrams is 3 significant figures, and then all the rest are exact numbers, and so this answer should be limited to 3 sig figs. So I think in Achieve, it would accept 51.0 kilograms per hour. Okay, thank you for listening, and we'll see you next time.